Next, let's take a look at how deep learning-based generative AI differs from traditional optimal design methodologies. Just like with predictive AI, using generative AI for optimal design enables non-parametric optimal design. For example, in the case of complex images, such as automotive images, it's impossible to express everything parametrically. By generating in this non-parametric way and linking it with a CA solver, you can find the design with the best engineering performance. In this case, the CA data is insufficient. However, if there is enough CA data, you can create a predictive AI using the CA data and then combine that predictive AI with the generative AI for training. Then, since you can generate and predict immediately in real time, it becomes possible to quickly achieve optimal design. Then, by optimizing in this way, you can recommend the best designs. The second advantage is that optimization can be done in real time. This is called inverse design. For example, let's say you are designing a cross-section of a brake as shown here. If we call the design X, then the performance that results from analysis would be Y's. So, the first thing you might think of is to create a predictive model where, when you input design X, you get performance Y's. But what designers really want is not a model where you input X and get Y, but rather a model where, when you input the engineering performance or target performance, you get an optimized design as the output. In other words, they want the inverse function, where Y is the input and X comes out as the output. When you train the model this way, you can get results in real time as follows. Thank you. You can obtain an optimal design just by inputting Y. Next, the third advantage is that you can generate synthetic data. Usually in industrial settings, for example, to build a predictive AI model, you need CAD data and the corresponding Y label values obtained by simulating that CAD data. But in reality, when you go to the field, there is a lack of X data. There isn't a wide variety of CAD data available. In such cases, how should we train the HGAI model? In that case, you need to generate this X data. That's why we talk about synthetic data, or what is called generated data. After generating meaningful synthetic data, that is CAD data, you can obtain the Y values through automated analysis. You can get the label values, and then, by training on these two types of data, you can obtain a Y-FX prediction model. Next, the fourth thing to consider is manufacturability. In manufacturing, since you need to create designs that can actually be produced, you have to teach generative AI about manufacturability. For example, if you want to use 3D printing, you need to train the model so that it can generate designs that minimize things like printing time or the amount of support material required. Or, if you plan to mass produce a product and need casting or injection molding, you need to train the AI so that it generates designs without undercuts, making it possible to remove the mold, or so that it can adjust the draft angle or the thickness, and so on. By teaching the AI these requirements, it can generate design proposals that meet them. Next, the fifth point is that by using deep learning, you can create realistic renderings that allow you to quickly receive customer feedback. For example, after finding a design proposal that is meaningful from an engineering perspective, you can then enter the prompt you want. If you say, make something in a youthful, blue-toned, very steel-like style, it will generate realistic images that look similar to actual products from a human perspective. You can then get feedback from the customer and quickly apply it to the design right away. More broadly, by using deep learning, you can combine the design and engineering processes. How can this be done with generative AI? When a designer makes a sketch, real-time rendering is performed immediately, and at the same time, the engineering performance is predicted and instant feedback is given to the designer. Normally, when a designer sketches something, engineers create a 3D model, analyze it, and then communicate the results back to the designer. This process takes a lot of time and money, but by using generative AI, the designer can work alongside a very fast engineer, achieving the effect of designing together in real time. So we've looked at how predictive AI and generative AI differ from existing technologies. In the case of predictive AI, I mentioned that it enables non-parametric predictions, can predict field values, supports multimodal predictions, can handle dynamic situations, allows for multi-fidelity predictions, can quantify uncertainty, and even predict customer preferences. As for generative AI, I mentioned that it enables non-parametric generation and optimal design, allows for real-time optimization, can generate synthetic data to assist predictive AI, takes manufacturability into account, supports real-time rendering, and can integrate design and engineering processes.